It's just a science project.
Silent breed is people!
You know, a doctor friend once said the same thing to me. Frankenstein was his name.
It's alive! It's alive! It's alive!
That sounds like something out of science fiction.
Please explain to me the scientific nature of the whammy.
We live in a spaceship, dear.
So? Yes, science!
Program complete. Enter when ready.
Hello and welcome to episode 233 of Science on Top for Sunday the 3rd of July 2016. I'm Ed Brown and I'm joined by Dr. Shane Joseph.
G'day all.
And Penny Dumsday.
Hello.
Firstly, welcome back, Shane. You've had an enjoyable few weeks travelling the world.
Yeah, I haven't talked to you buggers. It's been awesome. I'm only joking.
Lovely.
Well, that too. No, we went to the warm climes of Morocco, Malta, and Crete, and it was amazing. And then we came back here, and it's cold.
Yeah, great to have you back.
Yeah, it was a good month away from everything. So yeah.
Well, we missed you. We haven't done any bacterial stories for quite a while, and we'll be addressing that later on in the show, as well as talking about the similarities between dinosaur feathers and modern bird feathers, a new survival plan for a cute little mouse, and the importance of microbes in keeping our reefs healthy. But first, let's talk about California, where the severe drought is in its 5th year now. I think it was in 2014 that the governor declared a state of emergency, and I don't think it's improved very much since then. But a solution could be in sight, Penny, with the discovery of a deep groundwater reservoir that could hold 713 trillion gallons of water. And I don't even want to think about what that is in litres. I cannot do that sort of maths. But this is exciting and interesting news.
It is interesting, and I think it's probably more interesting than exciting at the moment for California, but it might be interesting with long-term planning. So these new aquifers have been found with a huge amount of water in them. The article I read said half the size of Lake Michigan, that's a lot of water. And it's pretty fresh. So, wow, could that be the answer to California's problems?
No, but Donald Trump already said that there's no drought.
Oh, sorry. I haven't been keeping up on my science Twitters.
I'm sorry. Anyway, continue.
I just feel, as an Australian, I'm reasonably attuned to droughts, you know. I'm like, oh, yeah, droughts, yeah. Like, it's just a...
I thought you were going to say attuned to Donald Trump for a second then. I thought, surely not.
So not attuned to Donald Trump. My husband reads his Twitter out of some kind of macabre fascination, and I can't even bear to do that.
I get that macabre fascination. Yeah. Not that I read his tweets, but I do get them. I get the fascination. Anyway.
I think it's... Yeah, anyway, we digress. So, there's this water, there's a drought. Water plus drought equals... no drought, right? End of all water restrictions.
Okay, great. Moving on.
Well, it's funny because California is already...
Yeah.
Oh, sorry. Well, I mean, so California's... From what I understand, isn't California basically... The only reason they can grow stuff in California is because of a huge irrigation projects that just transport water elsewhere? Because isn't California essentially a desert anyway, naturally?
I don't know. I mean, if that sounds reasonable, I think a lot of areas are. Yeah.
Like a lot of things, like the oranges and stuff they grow there. That's only possible because of irrigation and transporting water across vast distances to California. So it's interesting that they've actually found water underground here, which
Yeah, but unfortunately, it's not as useful. And one of the reasons that they haven't found it before, because obviously, it's not like Americans are stupid. I mean, they have looked for water in California before, but they're looking below 10,000 feet for this water. So this water is between 1,000 feet. So between 1,000 and 10,000 feet. And
how many is that? How much is that in normal measurements?
I don't know. 300 meters?
Yeah, so 300 meters, which is a fair distance to drill.
Yeah.
Yeah.
And that's the point, is that no one's really bothered looking for water that deep because at the moment, it's still too expensive to get it out. So this water's here, but it's hard to get out. The other thing is, even though it's fresh-ish, it's not as fresh as you would really like. So it has less than 3,000 parts per million dissolved solids, but the United States Geological Survey defines fresh water as less than 1,000 parts per million. So it's it's 3 times more salty than you'd like. And also, it's not just salt that are those parts per million. It could be other things. So if it's too expensive to get it out anyway, and it's not fresh enough to just use, you'd have to treat it. Why is this a study that even got into the news?
So my next question is, how do they so they've obviously sampled this water to discover its composition.
Well, what's the other thing that's really popular in California is oil. Like, think of the whole so there's lots of oil and gas wells. And that's why I think this is interesting. At first I was like, wait, this is a non-story. It's not interesting. They found this water, but you can't get to it anyway. But the point that's been made is that all this drilling for oil and gas and other things is that drilling and the movement that it can cause contamination of this water. So there is this amazing, huge resource of water there, but it might be worth considering management practices now to preserve it for some future time when it does become worth extracting.
You're asking the oil industry to
think of the future.
Look ahead.
Well, not so much the oil industry, but basically, I guess, government,
That too.
So it's not saying that, I think for California, just like a lot of Australia has had to just accept that drought is a reasonably normal thing to happen. We can't use water as if there's no tomorrow. It's restrictions and cutting back in water consumption are things that just have become a fact of life for a lot of people, which I'm not going to go poor us. Like, I think that, that's a reasonable thing to assume. However, if they can preserve this water and not drill too much and then maybe in the future it could be useful. I just guess groundwater is always difficult to use. I think people imagine vast underground lakes that you could, sail a boat. It's not like that. It's water. It's
trapped in
found
rock.
in tiny pores, like in the rock. So if you think of sandstone, it's little tiny holes that can contain water. And if you extract that water and you pump it out, you can get subsidence. You can get all sorts of other materials to flow in where the water was. It gets very complicated. I did not do hydrogeology past second year because it is very, very, very complicated.
It's fascinating, but it's also a nightmare.
Can I say, absolutely fascinating. Would have loved it. Can't do maths, so I had to stop.
We're very similar that way, Penny, to be honest. I'm a microbiologist who can't stand maths. It's like, exponential growth. Good on you.
There's only so far.
How do we actually detect this then? Do we know? Is this like a radar sort of thing or satellites or something?
No, this was from drilling for gas and oil.
Oh, okay.
So,
right.
So it's like a happy side effect of finding out.
The happy side effect is water that we can't use or even get to.
Can you apply your growth mindset here, Ed, that we can't use yet?
All right.
You know?
Yeah.
All right. There's hope.
And it might be worth, even though we can't use it, like something that is often a feature of mining and, not mining, but, using Earth's resources is that the first time you encounter something, it might not be economic to extract it. Like, why are you going to go mining for mineral ores if you can just get gold nuggets lying in a riverbed? But once you've taken that easy stuff, then it does become economic or worthwhile extracting the stuff that's a bit harder to get to. So even water that is salty and 300 metres underground, one day
might be valuable.
If you're desperate enough, then, it's going to be valuable.
Well, hell, with the way climate change is going, and fresh water will be increasingly scarce, I imagine this water will actually be more valuable and there'll be more of an incentive to start drilling for it, possibly sooner rather than later. So who knows?
No, in the same way that natural gas has become rarer and rarer, so we've resorted to things like fracking. It's probably going to be the fact that fresh water is becoming so scarce that we resort to drilling into this.
We'll start to do this kind of stuff. Well, we're already, exploring desalination and,
which we'd have to do for this anyway. Yeah. All right. Let's move on. And a pair of wings found encased in 99 million-year-old amber suggests that the plumage of modern birds has remained almost unchanged from their Dinosaur-Era ancestors. These ancient wings, Shane, are immaculately well preserved, aren't they?
Yeah, they are. I mean, this is the magic of amber. Like it is one of the best preserving materials, I think.
We've all seen Jurassic Park.
Well, yes. Yeah, I didn't want to say that because we know how inaccurate that is. Just in terms of, obviously you can't get DNA out of these things and you cannot clone a little Cretaceous-era hummingbird. So, sorry. But what is amazing about it is that it bypasses a lot of these sort of the more normal fossilization routes in that you get sort of deposition of minerals in place of bone. Unfortunately, that doesn't work very, very well for bird bones because bird bones are hollow and they get crushed. So you get, there are some sort of so-called traditional fossils of birds, like I think or bird-like dinosaurs like Archaeopteryx, for example, where you see beautiful feathers and things like that and muscle structure and stuff, but it's very, very rare. However, in these amber samples from Burma, which apparently about 30% of the Burmese amber samples have fossils in them,
wow,
you can get feathers, and apparently it's quite prized in the Burma. Like normally with amber mining, they don't want impurities in that, like fossils. They consider things like insects, mosquitoes and things like that have been caught in amber. They consider those impurities, so they just chuck them out. But apparently, bird feathers are, because they look very nice, are prized in this amber jewelry. So they actually are. That they take pains to preserve it and to polish them up, and in doing so, they usually destroy the sample, or at least they'll chip off bits of the. They'll chip off apparently these two fossils might have come from originally it might have actually been part of a bigger amber piece that might have contained an entire bird, but they've just chipped off bits of it because they don't really care about the bird. They want the feathers instead, which look very, very nice, which is a bit of a tragedy in itself because.
Yeah. That's extraordinary when you consider how much sap you would need to cover a bird for it to become...
Well, they're only little birds. They're only little hummingbirds. And these are juveniles. So, they think that they're pretty sure that these were juvenile birds, which is actually amazing because they look at the size of the feathers and everything, and they've realised from this that these Cretaceous-era birds actually matured a lot faster than modern birds do. So when birds, especially this species that are close to this one, nowadays, as they say in the article, they hatch out of their eggs and they can barely open their eyes. They're pretty useless. They rely on their mother for everything. These birds appeared to be much more developed at the same age, which means there was probably... What's amazing about this study is just from these wings and from the size of these wings, they can extrapolate the age and they can tell that, okay, these birds were probably a lot more mature because they had to mature faster because they didn't have the same familial help as modern birds do. So they can already tell from just this feather, they can already tell something about the life of these animals. 99 million, which is pretty incredible.
It's extraordinary.
Yeah.
But also there's the similarity in how the actual feathers and that are structured to how modern bird feathers are structured. So there's been little variation over 99 million years, I think, which is, I guess, evolution's way. And you've got a good thing, you stick to it.
Well, it sticks around because it's successful. Yeah. Unless something, nothing else came along that was better than the feather, so it stayed around.
True.
And we know that most dinosaurs had, I think possibly all dinosaurs had feathers.
Not all, but most, I think.
Not all, just most. Okay. Well, okay. We know that it was very, very common, so it seems to be one of those things that has evolved, possibly numerous times, but it has stayed because it has been successful. Yeah.
Very cool. All right, well, let's move on to England now, where the wildlife charity, the People's Trust for Endangered Species, have teamed up with the Yorkshire Dales National Park Authority and released 38 rare hazel dormice into an undisclosed woodland location in an attempt to stem the decline of the species. And Penny, we've all seen mice before, but this hazel dormouse is a particularly cute little thing, isn't it?
Oh, it's very cute. And I think maybe one of the reasons that I was attracted to this story is if you start reading children's literature, as I read a lot of, often dormice feature. I feel like they're my friends. So anyway.
Your friends.
They have so many anthropomorphic traits.
Was this a Beatrix Potter? Was it a Beatrix Potter thing? Or
yeah,
no? Or,
among others. So,
Okay, cool.
But anyway, so it's not so much the dormice, because I think the story of something from a captive breeding program being released into the wild is not a new one. But what I find really interesting is the English landscape, because in many ways people have been living in England for thousands of years, and I think as Australians it's not just living, I should say, but sort of managing it in terms of fields. So that some of these hedgerows and woodlands that the dormice live in, and which means essentially the fields around them, so the way that the land has been divided by people has been like that for hundreds, if not over 1,000 years. So there's a rule of thumb that you can see how old a hedgerow is by counting the number of different plant species there, or significant plant species, and however many plant species, that's how many 100 years it is old. So you have all these things that are 500 or 600 years, that fields have been in place for 500 or 600 years. So, and people have been maintaining them. But what's really interesting, I thought, about this is because people have stopped using them in that traditional way. And this is something that we see in Australia also. Indigenous people manage the land in often quite intensive ways. And Europeans came in like, oh, no, it's all natural, pristine, we mustn't touch it. But when people stopped managing it, it really changed. And there's this disconnect between what's natural and, it's not an easy question.
Yep.
In England, people would have had all these traditional uses of the land, like collecting fuel and grazing pigs and stuff. But people stopped doing that post-World War II, and a lot of these hedgerows and woodlands are just not managed anymore. Like, people might walk their dogs through them, but they're not going to go there collecting firewood, because who has a fire, They're not going to let their herd of pigs go there anymore, because no one's got a herd of pigs. It's much more economically practical to work in IT. So strangely enough, what seems strangely is like less attention from people has in a way contributed to the extinction of the dormouse in the wild, because the woodlands and the hedgerows aren't being managed. So
it's not like your typical extinction where we think of, we hunted something to extinction or something. This is just that we haven't been there as stewards of the land to maintain it, and it's failing to survive in that new ecosystem.
Yeah, because instead of the rows of hedges that were really managed, you might just get a row of trees with less undergrowth, and that's not as good for dormice to live in. Wow. I'm sure if I lived in England, I would probably be more able to explain hedgerows and their significance. Anyway.
I think you've done a good job so far.
I've tried. I find it really fascinating. Anyway, so this population of dormice has been released. There's another population a few miles away that have been released. So hopefully the two populations will connect up. They will start to self-sustain in the wild.
Yeah, very cool.
Yeah.
And the article on The Guardian also has a list of other lost British species that have either gone extinct in that area or are declining. You've got, the lynx, beavers, wolves, sea eagles, and the wild boar. It's amazing the impact that we have both when we're trying to mould the landscape to our desires and when we're not moulding it and we're leaving it unattended, I guess. It's very cool.
I find that really interesting to think about.
All right, speaking of landscapes and endangered places, let's talk about coral reefs now. And a 3-year-old study of a reef in the Florida Keys has shed light on how microbes living on corals are crucial to keeping the reefs healthy. And things like overfishing and pollution and climate change can all act to destabilise those microbes and the corals' natural defence systems, Shane.
Yeah, this obviously has parallels with what's happening with the Great Barrier Reef in Australia at the moment, because as far as I'm aware, the bleaching of the coral reef has been pretty horrible. And that's basically due to increasing temperatures increasing sea temperatures, which have led to the killing off of the coral. What this study has shown, and this is basically a simulated study. I think from what I can gather, they basically set up a little environment which simulated coral reefs, and They looked at things like bacterial diversity with changing temperature and how much algal cover affected this, and then how much pollution affected this in the form of extra nutrients being pumped into the system. And they found that, what happens is that when you introduce things like temperature changes, when you introduce things like excess nutrient, from what I gather, it's a very complex system, but what essentially happens is that you get a destabilisation of the natural microbes that live on the coral. And this can lead to a destabilisation of the entire fauna that live around it. And it makes the coral more susceptible to damage from things like parrotfish. Now, normally parrotfish, for example, will go and bite at coral and damage it. But in a normal situation, the coral recovers very, very quickly. But if you destabilise the microbial populations on the coral, then all of a sudden you've disrupted the entire system, and so these corals don't recover. Or at least they recover a lot slower.
I wonder why that is. Is it something that the bacteria is doing to help the coral recover, or is it something that it's doing to ward the parrotfish away? It takes a bite and it doesn't taste right and it goes or something?
That I'm not sure about. I mean, I have a feeling it's a very, very complex system. It might even have to do with things like, I know, for example, with things like biofouling, for example, you need, normally bacteria and algae and corals live together in a sort of it's an equilibrium generally. But if you disrupt any of those systems, like if you take away something from that, you'll increase opportunism for another thing. It's a bit like when you take antibiotics in your own system and, you flush out your system and you get candida infections.
Yeah.
It's something very similar. I think I've got a feeling it's something like that, and I might be wrong. But from what I understand, it's essentially when you disrupt that equilibrium, and that could be in the form of anything. Like it could be in the form of just simple temperature change, which stuffs up the entire working of the system, which then leads to other things coming along. So, it could be that the parrotfish normally eat, like when they sort of nip at the coral, they get the bacterial populations instead, like the bacterial biofilms that are growing on the coral. Whereas if you don't have the bacterial biofilms because you've killed off or you've disrupted the community, the parrotfish are actually eating at the coral instead.
Yeah.
So that could lead to more damage that way, I think.
Yeah. Towards the end of the article, they talk about suppressing algal overgrowth and blooms of harmful bacteria. So it could be just that it's the good bacteria versus the bad bacteria again.
Something like that. I mean, but what I think the take-home message is here that you've got things like overfishing, which, that basically stops things like, fish will generally feed on the algae. So if you have overfishing, you've taken away the one source of algal control.
Yeah.
Then you get blooms. If you increase pollution, you are basically stuffing up, you're putting in excess nutrient, and certain bacterial populations can't cope with that, so they die off. Then you get more algal overgrowth.
And you get raising temperatures as well is going to grow more harmful bacteria.
Which also feeds into that. Yeah. It's honestly, take-home message from this is it's an extremely complex system that is being attacked by multiple sides, and that's probably a big reason why corals are dying.
And we need to focus more on that sort of conservation and trying to reduce climate change effects, trying to control overfishing and pollution.
Yeah.
It's a bigger problem than we thought.
Well, I mean, the easiest thing is firstly to control. The easier things really is to reduce the amount of pollution we're introducing into these waters, and also overfishing. But I say easy, but it's one of those things that it's more easily controlled than, say, a rising temperature.
Yeah,
you can have you can put in place stops to those things more immediately than you can stop rising temperatures of the ocean. But in the end, it's all it's a complex system, and it all feeds.
It's a dire warning that we need to be better managers of our oceans as well as our landscapes and our fields and hedgerows as well. Yes. Not the happiest note to end on, but maybe an important one, I think. But I think that's our show. All the links, of course, will be in the show notes and on the web at scienceontop.com/233, where you can leave a comment or find our social media links. You can also send an email to feedback@scienceontop.com, and please leave us a review on iTunes. Penny and Shane, thank you for joining me today.
Always a pleasure.
No worries.
This episode was edited with a half-eaten democracy sausage by Marcos Benamou. Thank you. Thank you, everyone, for listening. We'll be back again next week, putting science on top of the agenda. Join us then.
prepared a contingency communications procedure. And guess what? We don't need that anymore. History. So tonight, through tones, Juno sang to us, and it was a song of perfection. Do you realize that after a $1.7 billion billion mile, they're going to kill me. After a 1.7 billion mile journey, we hit our burn targets within 1 second on a target that was just tens of kilometers large. Isn't that incredible? That's how good our team is. And that's how well the Juno spacecraft performed tonight.